Hello, this is a follow-up video on estimating pi with random numbers. Now, I tried my best to put this video in the middle of the previous video, but my machine is so old and slow it kept dying and it would crash. And so I'm making a separate video. So here we want to estimate pi with 1 million random numbers. I guess technically it's probably 2 million because we use 1 million for this set of numbers and 1 million for this set. But I like to think of it as 1 million pairs of random numbers. And if the random numbers fall within a unit circle, then we count it as 1, otherwise it's 0, and add up the number of times they fall in. And that's what this represents. So with 1 million pairs, we're at 2 decimals. And so let's actually do 10 million and see what we get. 10 million pairs of random numbers. There we're accurate to 3 decimals. And let's do 40 million pairs of random numbers. And we get, oh, see how slow my machine is? We're accurate still to about 3 decimals. Now, one thing that I was intrigued with was the convergence. And so this next one I'm going to plot, the convergence. So after every point, we're going to come up with an estimate of pi. And then we're going to do that 1 million times. And that's what this will represent. And so this plot is every point is an estimate up to that point. It's a cumulative. So the last dot on this plot is 1 million points. And look how it kind of converges, stays below, then it goes up, and then it hovers around it. That's after 1 million random points. Now, let's do it for more. So I wrote a little code here, and I looked at 1 billion points, a cumulative. So after it looks at a million and then plots the estimate, we look at another million points, combine it with the previous estimates for 2 million, and then 3, then 4, then 5, so a cumulative, and then we see how it converges. And my machine, while I did it for a billion, and it takes about 5 or 6 minutes to run, I didn't think that would make a great video. So I'm going to do 100 million and plot the estimate every million. And so that's what this code does. And so the n of a million, so that's, I create vectors of length a million, and then we rep it 100 times to create 100 million. And we keep the estimates in that variable estimate pi, and this is it. So notice though that we're already 3.14, we're almost within 1 or 2 decimals, and then it really starts honing in and hovers around the estimate of pi. Now, to me, it's a little surprising. Even at 1 billion, we're still only 4 or 5 decimals accuracy. So this really converges slowly and would take a long time to get a good estimate of pi. But in theory, asymptotically, it does limit to pi. Well, I hope you enjoyed this video. I sure did. Now I'm going to copy and paste this code into the comments if you want to copy and paste it into an R program and play around with it. So hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.